index value. That's important because when we try to access components to a vector or for a data frame, we use this square bracket notation to pull out particular elements of that vector. So in this vector here, let's call it something. Let's call it my vec. So I've assigned this 3-element numeric vector to the object named myVec, and then to access it, myVec, open square bracket, and then index value. So what should that return if I were to run that code? 5. Does everybody see why? So the name of the vector, open square bracket, the position number, and then close square bracket. We mentioned this term syntax a few different times. So syntax is sort of in computer science world is the way that we talk about the grammar of a particular language. So it's literally how we write that language out such that the computer can understand what we're saying. So the syntax for this particular line, just like I described it, it's the name of the object, and then an open square bracket, the index position, and then a closed square bracket. So we talk about syntax errors or things like that. We're referring literally to the things that we write such that R can understand what we're trying to say. We talked about conditional statements. So the double equal sign is saying, backing up. So conditional statements are things that evaluate to true or false. And so we've got a few different ways to do that. The 2 equal sign asks, are 2 values equal to each other? So it's is equal to. I can't remember if we talked about this one last time or not, but by putting an exclamation point before the equal sign, it's saying is not equal to. So that exclamation point signifies it is not. And we'll see that a bunch today, I believe. Greater than or equal to, less than or equal to. And then we use those conditional statements to pull out pieces of this vector or of this data frame based on whether they meet particular conditions. So we're going to get much more into that today with dplyr. Oh, and then the pipe, right? We talked about the pipe as an operator that takes everything that's on the left side of it and passes it as the first argument to the function on the right. Any general questions about the concepts we went over last time? Great.
Awesome. All right. How many of you, sorry, as I'm eating brownie and drinking water, how many of you feel like the biggest hurdle for the assignment last week or this week was just pushing stuff to GitHub? How many of you feel like it was actually getting the script from your partner and getting it onto your computer and running it? No, okay, good. Well, start. So I had lots of good questions about how or why things weren't getting pushed to GitHub. And I think this process is going to get easier, I promise, I hope. It's sort of like Defense Against the Dark Arts. Like, we just have to sort of keep at it, and, you know, failure is very common, and we will get better, I promise. We will get better at teaching you how to do it, and you will get better at practicing it. Anyway, I think let's walk through really quick just the assignment, just so you can see kind of what I did. But in looking through all the comments, you all did a really great job of reviewing the ones that I looked at, each other's code. And I just want to say thank you. That's great. And I think as we go forward, it's awesome to be able to run other people's code. And R is both amazing in that you can run the same simple assignment many different ways. But it's also maddening in that you can run the same thing multiple ways. And as you go forward, I think you'll find that is very common as you get more confident in sort of the way you write your code or the things that you use. You'll find some ways to do things are actually much more simple and use less code. And so the more time you spend sort of scripting and coding, oftentimes what happens is, hopefully, things get simpler, right? You figure out different ways to use things, and you're like, actually, this only takes 1 line of code versus 10 lines of code, right? But having said that, they're both the same thing. They get you the same answer. There's no wrong answer. So having said that, let's quickly jump over and look at, oh, I should open the So I'm going to open my new session here, so separately, so I can run this. And okay, let's see. This is what we're looking at. Okay, so section breaks are super important. One thing I wanted to show you that's kind of cool that I just learned pretty recently is if you type TS and then if you hit tab, this pops up and it's a snippet. So in RStudio, it has its own little kind of fancy little shortcuts sometimes. So if you type TS and hit, it basically stands for a timestamp. And if I hit enter, I get a timestamp of exactly today at this time. So this is a really, yeah, everybody's like, woo. So this is a really handy thing because imagine you're writing a script and you're like troubleshooting, you just can't get anywhere. And you're like, I need to stop. And this is reflective of sometimes what I do. I will stop, but then the next day I'll put this little break so I know, okay, I'm starting at a new point to try something different, okay? So, but it's a nice thing to throw in there. So let's move this up, or delete this section. So we've got a title, and then here's a section. So load library. Let's see if I can get this. There we go. So let's look at our outline to see our sections, right? Remember, this is the outline button on the upper right. So we've got load library, download data, load the data into R, filter and select, and then make a histogram. So it's pretty well laid out as far as like, these are the things this script is going to do. Great. And if I want to skip the load library and just go straight to download data, if I click on that, it'll skip to this section. Click this button. You don't need to have all these things. I'm just showing you sort of the pieces that I've included. Now, one thing that is going to be interesting and going forward with, we're starting with a new repository, right, this week. It's really important that people use the same all lowercase folder directory names, right? Because I noticed a lot of folks had uppercase D data, and then some had lowercase data. And the problem is if somebody tried to run, you know, one and they had the other, it will break, right? If you try to run this line to download this file to a data folder, but if it's data capital D, it's R is case sensitive, and it will say, nope, can't find that, throw an error. So the first thing I did here is we download the data, so everybody has the same data set. Then, and I put a note in here, check path to make sure a folder named data exists in your project. So hopefully pretty clear. Then we're gonna load that data into R, because now we have the data on our computer, but it's not in R, right? We need to get it into R to do stuff with it. So now we're going to use our read underscore CSV. And again, if we load it at the very beginning, tidyverse, we don't necessarily need this reader : : I'm just including this to indicate that this function is part of this package. And this is a handy shortcut in case you don't want to have to load a bunch of packages and you're only using one function. This is a way to do it. You basically say the library and then, or the package, and then the function. All right, so we load the data. So let's go ahead and do that. Right, and there's like a lot of stuff in here. So surveys, we got record ID, month, day, year. Notice that it does give me the NAs, right? So one of the questions was how many NAs are in the data set. So you can use summary simply to grab that and find a column if you want. So that's one way to do it. I noticed a lot of folks used is.na, which is totally great too, but we hadn't really covered that all that much. So head is another way to check. So let's just quickly look. That's what the data set looks like. And again, because we're using the tidyverse and we did read underscore CSV, it's reading this in as a tibble. Instead of if we did read dot CSV, it would read it in simply as a data frame. And the difference is if the data frame, when I print it out, it's going to look more like, it won't have all this extra nice information about like how many rows and columns, what the different data types are, all this stuff. It will just be strictly just the data. Tibble is a data frame, but it gives you some additional information. And then finally, dimensions, so 34,000 rows and 13 columns, right? And then structure for str. So structure is, prints out a bunch of stuff, but gives you the information here, which is the same information that's down here in this little arrow. If I click this, I can see that same stuff. All right, cool. So now let's talk a little more dplyr. So we're going to filter, and filter all the tidyverse functions require, what's the first argument always, typically? What's this?
Data set.
The data, right. Which is kind of nice. You always start with the data and you know that that's the first thing. So we're going to filter surveys, and we're going to filter, we want hindfoot length that is greater than 10. And that means it's sort of linking these together. Month greater than 4 and month less than 11, because I said May through October, right? So inclusive of May and October, this would be less than 4, greater or less, or sorry, greater than 4, less than 11. I could similarly change that, and I saw a lot of different ways to do this. You could do less than equals 5, and less than equal, or yeah, you get the point. I'm saying it wrong, but 10. Oops, that's not right. There we go. So that would be the same thing, right? And yes, and then the pipe, and I'll take questions right after this line. So then we've filtered our data, and then we want to just select the columns of interest, because I don't want all the, there's a ton of columns in here. I just want the ones that I'm going to work with, which were weight, hindfoot, month, and species ID. So pipe, again, this is Command-Shift-M, I think is the shortcut, or Control-Shift-M. And then select our columns. And we don't need data here in the front because we're using the pipe. Okay, now questions. Many questions. Is it Emily?
On line 29, where you have the and symbol,
do
you have to put that, or can you put like a comma?
Great question. Comma is the same as and in dplyr. Yeah. I use and because I find it's a little more clear. If somebody's reading it, they're like, oh, this is and. So if you're doing like query, SQL queries and stuff, you always use it. But comma means the same thing. Do folks remember what or is? What's the symbol for or in R? Or in this? It's a vertical bar. So if I use, whoops, let me turn my mic off. Sorry. If I used here, instead of an and, if I use this bar, what do you think is going to happen?
You're gonna get a bit more.
Get a lot more data, right? Because it's going to first match this, everything that meets this, or everything that meets this. So you're sort of having two separate data things that it's looking for, which can be handy if that's what you're after, but in our case, it isn't.
Will that or just after, so we'll just get them off and
right. So it will interpret this as one whole thing. Right. Exactly. So yeah, it kind of breaks things apart. So the way you can couple ands and ors we'll play with that a little bit more because it doesn't matter. Like you put an or first or an and how you chain things together, but it's really flexible and really powerful in how you can slice and dice your data. So we're going to play more with that today. That's most of what we're going to do today. Any other questions? Yeah.
My partner had double equals 4:10, and we got really different answers.
4,
did that work?
5.
Or it was sorry, 4, 5:10.
Like that?
Yes.
Okay, so let's look. Oops, I didn't load my library. Okay. All right, what's breaking here?
Yeah, and then there was a little warning that said, longer object length is not a multiple of shorter object length. But it still returned an answer. So I didn't
Still right.
notice.
Right. So in our, let's look in our environment here to get a better sense of.
Each have 5 and 10 equals.
So what is, first of all, what does this mean? Just 5:10. 5 through 10 in R, right? So, and then what does this double equals mean? Is equal to. So it's sort of saying any month that is equal to 5 through any number in 5 through 10. So technically, I think so. We have surveys 2, 26, 20, and then let's go back to the previous version and see what happens. So now we have 15. Doing this version, we have 15, 5 to 7. So what is happening here? I'm open to suggestions because I'm not totally sure either.
If you do the percent in, and then you see 5 to 10.
The right answer, right? So that's more of like how I would. So she has another great way you can do this. Is there's another sort of option to say percent in percent, and then if you did 5, because then it basically makes this a list of numbers, 5 through 10.
Did you still click at cat?
Nope. It recognizes 5 through 10. Like a list of species that I was interested in. I could, instead of, if this was species, I could say C, and then you would add your quoted list of species, right? Which would be kind of a nice way to do it. We can play around with that. So what is happening exactly with the equals 5 through 10? I'm not exactly sure, but I think it has to do with that equality, that double equal sign, and it's sort of trying to match. I think it's trying to match anything that fits exactly that. Yeah, Michael.
I think it might actually be, I think sometimes with selecting equality like that on a list, it's just taking the first vector in that list. So if you try just equals 5, that might be the same thing. I think it's only 26, 20.
28, 20.
That's weird.
Yeah.
Don't know why that is, but I think it's something like that. How is it optimal? That's gonna kill me.
So yeah, that's a fun thing. I don't know, is the short answer. So one thing I just did, which we haven't, most of you may have already looked at this, but a really fun, quick thing you can do in RStudio, which is nice, is if you single click on this, it will open it up in this nice little window. And then the other cool thing is you can filter in here. You can search for stuff. So if I wanted to say I want only species that are NL or NA, it'll highlight those, and you'll see it showing. It'll tell me there's 107 NLs, and it shows all of them. So you can slice and dice and filter this as you like, which is nice. So if you just click on just click here, it will open up this little window, which is the same. Notice that it's actually running the command here too. U is the same thing as clicking. Okay, so let's. So that was fun. I didn't know that you could do that, but we'll have to ask somebody who has a better feel for that and figure out what's going on. So let's use that one. This is, I think, the data set that I was envisioning. Yeah, that's the one. Okay, summary. So now this is the one that I was going to use to see how many NAs there are. So 389 NAs in weight. A lot of other folks use is.NA. So surveys to weight. And then if I wrap this whole thing in is.NA, what happens? It prints out whether it's true or false, but it's the whole vector of it's true or false, right? So that's not super helpful. So how can I get the sum? If I wanted to use is.NA, how might I do that? Sum to the front, okay. $389. Sweet. And somebody said count. So count is a function that's, I think, part of the flyer here, and so you have to use it within this. We'll play around with that a little bit later. But yeah, sum would work. So that's another way. And then table is a great way to just quickly look at the different species here and identify I think I said the 2 least. So AH, there were 2 that had 2, an RO, and then the most was DM, I think. Okay. And then finally, histogram. You can get as fancy with this as you want, but it's literally just hist and then the column of interest. As long as that column is numeric, whoops, you may get this error. This is actually pretty common. Error in plot.new, figure margins too large. That's because it's trying to plot it in this tiny little spot down here. So if you resize your windows and rerun the command, there we go. Okay. Any questions on that? Awesome. All right. Onward. So I'm going to switch over to my live code. But at this point, I would love everybody to be in your, I haven't cloned it yet, and I don't want to take time to do it, but I want you to be in your tidyverse repository if you haven't created it already. That's where we're going to be doing everything going forward. Okay, so new project for the tidyverse. I could go do that right now if you want, but why don't we'll start here. So let's make a new script in your tidyverse repository, and you can call it dply or week 4, whatever you'd like for today.
A folder with like a folder, tidyverse folder within the scripts.
So, right. So let's actually. That's a good question. Let's go. Just go get that thing. So let's go ahead and just walk through this. We might as well do the whole thing. So I'm going to go navigate to our. Oh, actually, that's not it. I want to go to my classrooms. And I'm going to. You all don't really have to see this, but I'm going to go basically go ahead and clone it myself so that we all have this same. This is the email I sent you all. And so when you click on the link, you should get something like this, right? Accept the assignment. And then all it's going to do is append. It's going to say, okay, you're going to get an invitation. And it's going to append my username to the end. And it's going to clone my repository, which is pretty quick. There it is. So let's clone this. I'm going to copy that link. Let's go to RStudio.
Yeah.
Okay. In okay. In our GGEUCD, you should, well, we might have to change the email settings. This is the part I was worried about, Mike. If I post here, some people may not get it.
Yeah, I didn't.
So ideally, what everybody, hopefully, you can change your email settings in GitHub so that if you get sort of notified you're part of this group, which you all are, you've all been added to this, anytime I post here, you should get an email saying like, hey, you got something's posted here. Alternatively, I can go ahead and email everybody on just a Gmail to the class, having it here because then it's in one place and it just makes it easier. But if folks aren't getting it, then I will send a Google email as well. So I apologize. But if you go into, so let's back up. Thank you, and I apologize. So it's probably good to go through this. So here's our home organization, right? Under Teams, You may not see this. I see this because this is last year's class. They're the Ewoks. We're doing mythical creatures, I guess, is the theme. Ents is our group. And in here is our discussion. So anything, ideally, that I post in here, you should get a note about, an email. And you can set in your settings over here, I believe, if you right-click in settings, you might be able to change your email notifications. So maybe check in here and see if you are getting it set to sort of get email. Maybe it's unchecked. I'm not really sure. But that would be something to look at. Okay? So the link, however, is in here. This is what I said, like, hey, great job, everybody. If you're having trouble, just email your partners. Here's the link that I just clicked on. So if you haven't done this, go to this place, click on that link, accept the assignment. Okay, and then we're going to do exactly what I just did, which was it's going to create a repository here. And then I'm going to, so maybe if somebody doesn't mind pasting that link, this link into the Google Doc, could somebody do that, please? Thanks. Make it easy. And then we're going to clone this. So I'm going to do that and then go to our studio. And I'm going to make a new project. All right, so is anybody questions up to this point? How many people have not created a repository yet? And it's totally fine. I apologize. I didn't realize some people didn't get it. So fair number. All right. So if you have your repository all set up, green sticky up. If not, why don't we take a minute to try to do that? And I'm going to walk through the process right now. I'm going to open project. Oops. New project. Version control. Git. Setting. Yeah, just make a new script for today. Yes. Me too. Evidently. Hang on 1 second. So mine's throwing an error, if anybody noticed. So I'm going to go ahead and try to do it manually. Uh-huh.
Otherwise, I need to do I think it's tools and then turn it on to say.
She doesn't have that. All right. Try it this way. Evidently, I can't do it today. I see one thing sticking there. On a Windows? Yes, hang on 1 second.
Okay.
If you right click, oh, go ahead, Taylor's got it.
Remember history.
Okay. Whew, that was fun. Okay. So if you haven't, why don't you go ahead and in your script, let's make sure you have your data. So download the data to the data folder with this line and go ahead and read it in surveys because we're using surveys data.
So we're using the same thing.
Yep, we're using the same exact thing. So, but now that we're going to do put the data there, right? So why don't we run that? Yeah.
Sorry, I don't have Steve here.
Oh.
What is this website that you're getting all this?
Our database. Where's the green one? Yeah, the R database. It's the. Can somebody help her find the? Thank you. Okay, so I think hopefully is most everyone here. Not yet. All right, I'll give another minute or so.
You're on this one.
Well, I'm using the live code. Yes.
You're not going to be on the same project.
You should all be in your learning tidyverse, and you've made a new script, and you're, yes, you should be there. I'm going to be in this project because we're live. This is the live code so that you can update and see stuff. Okay. Yeah. This link? Oh, it's in the, so this is the live code. So pause for a second, everybody, listen up. There's a reason I'm in this project and not in the Tidyverse project. Again, remember this is the live code. And if we go to our website, where is it? Here we go, and under lectures, week 4, here's our screencast, our Google Doc, and live code. So if you click on the live code link, it's going to open this up. And if I refresh this, you should see, there we go. So you should, pretty much from here on out, we're going to always have those sort of things all linked up there. So you can always find it on the website. Any questions on that? Good? Yeah.
Okay. Now, go to this. Go to that. Now, you have the SSD. Don't see. Version control. Now, there you go. And decide where you go. And then you're going to put it, and now say, that's loading the repository. So now, you got the so now go back. Now you say new folder. Okay. So and now you're going to go and you're going to say new, so the on the front left. Do you have to say new folder? And this one you're going to say on the switch folder this repository. It's the week before in class.
Yeah, so I wasn't change I didn't know that. That they don't exist.
Okay, so let's try to move forward here. How's everybody doing? Are we mostly good? Okay. All right, so we have now read in our data. Let me open our studio. And we're here. Okay. Always fun. So load tidyverse, which I should have done before. Okay. All right. Phew, that was exciting. All right, so now, hopefully, these things always are more complicated than one would think, and that is okay. So I did show filter a little bit, and I want to start sort of there again. Let me make this a little bit. There. So one of the things I want to talk about is filter. And I'm going to show you how to filter both in the base R sort of way that we've been doing with the brackets, and then also filter in tidyverse dplyr. So we have this data set, surveys, which is really big, right? Let's look in our environment here, and it's 34,786 observations. There's a lot of stuff in there. That is messy intentionally. So let's filter to a single year. So here's where the double equals might be useful. Let's filter to just 1 year. So this spits out something that is 1,180 rows and 13 columns. Same thing in base R. Surveys. So we haven't talked about it much, but one thing you can do is use brackets next to your data frame. And remember, when we subset, what's the first thing here? First rows and then columns, right? So if we wanted to select year 5, but we want all the columns, how might we do that? Well, so we want to leave, the columns blank because we want all columns, but we want only rows that are equal to 1995 in year. So how might we do that with these bracketing situations? Surveys is $, year. Yep. Okay. So now get the same thing. Okay. So these are the exact same thing. They're just in one is in base R, one is in dplyr. If we wanted to start chaining these things together, so let's say, where's my mouse here?
So base R just means that you're not using a packet.
Correct, yeah. But when I say base R, that's like the base thing that when you all install R, it comes with everything, sort of the defaults, right? So why don't we start using some pipes, because I think that's where you'll start seeing things get more exciting. So let's couple a filter with a select, right? So we want to select some columns and we want to filter to a certain thing. So let's use filter and select. Let's say filter surveys, we'll do the same thing. Year equals 1995. And like remember, I can use a comma or an and, right? So I'm going to use the and symbol just so it's a little easier to see or read. And let's say weight less than 5. I can type. There we go. Okay. So I'm going to run this really quick to see there's no values with that. Let's say greater than 5. There we go. All right. There's some data to work with. Okay. So great. We've got some data. Now let's pipe this and select, right? Now we want to select. Now select works on columns or rows? Columns, yeah. So let's say species ID, year, and weight. Okay, so now we have this pretty clean data frame where we have species ID, year, and weight. All right? What if we wanted to do the same thing in base R? Now, what are we thinking? How might we do this? I'm doing this because you'll find some people prefer to do stuff in base R, which is completely fine, but I want you to be able to read both and do both. And sometimes you need to use base R and sometimes you don't. So surveys, right? So I'm going to just add what we had above. Surveys, year. Sorry, I should be adding a little space in here to make it easier to read. Okay, we have that, but we need, what else do we need? We need weight greater than 5. So what, do I just add that right in here? And one of these things that is and weight greater than 5. Aha! You are all awesome. Okay, so we have that. Now, if we want to select, so I'm going to use the pipe because you can. You can use it in base R as well. So first, let's run this just to make sure it works. Yep, looks good. Okay. So now let's use the pipe. Now, how do I select using base R in the brackets, basically?
You have to know the numbers, right?
You could use the number, but you don't actually need to know the number. So first, what do we need to do to subset to a set of columns only? Surveys, bracket, all the rows, but we want columns, right? So we could look up the number and we could list the numbers using the combine. So I could say I only want columns, whatever they are. I'd have to go find them. So maybe in here I click on this and I count like, all right, well, what number of column is it? I could do that. That works. Yeah, what if I just know the column name? I just want to put the quoted column name. That might be a little easier. Species ID, year. Wait. Oops. What happened? Right, so yeah, exactly. So the problem is this is looking for this value, but it doesn't know where it's in surveys, but it doesn't know is it in a row, a column, or necessarily. So yeah, so actually instead of quoting, I probably need to do this. Or I can do this. There's multiple ways to do this. I'm showing you one. Oh, what are we doing here? Aha, thank you. Nope. Any other thoughts? Oh, I have an extra comma there. Nope. Right, so let's try the numbers way. So one thing I could do, way that I might be able to do this, show you another way. So surveys, or let's use this one, column names is a function. And I'm going to use the percent in percent. And then I'm going to make the, try this. Yeah. Yeah. Anybody can help me? Yeah, Mike?
I think the first way that you had it would work, and I think the way you currently have it would work. Don't want to fight your previous.
Right. Thank you.
thing to it.
Got it. Can't pipe. Yes. Thank you. So I would need to assign this to something. So this would be like filter A. Thank you. This would be subset. So let's try this again. So
But then
what?
you have to call it filter.
Haha. You guys are catching on quick.
This is all intense.
That's good. So this is why we live code and do stuff, because it helps. The more you start spotting stuff, the more you're going to be spotting stuff in your own code. Yeah, Michael.
Yeah, one thing like with the pipe that it took me a little bit to like get, but I think it's helpful, especially if you're trying to use pipes in a broader context, is that the pipe is just taking everything on the left and saying put that as the first argument into a function on the right. It's just saying put it as the first thing, which in the tidyverse is always your data. But when you're using it in a context like this, there's nowhere for it to put that pipe information, because it's like, what argument are you trying to put this into? Where are you trying to put this?
So there are ways to change. Yeah, so there's ways to pipe it, but we would have to be explicit about what we're piping specifically and where in this is that data that Michael's talking about, this big pass from here to here. Where is that going? And I don't really want to go into that right now because it's not very easy. Anyway, so we could do this, right? That's one option, or what I had previously would have worked as well. So let's change this to the previous iteration.
So that's like fundamentally the computer is doing something different with the code in base R than it is in tidyverse. Or no?
That's a good question. I don't know the underworkings as well as like what dplyr, how dplyr is operating on something, but the way that it is querying and working with the data is different. Yes.
Which is why like that same thing works.
Right. Right. But ultimately, it's all using the same data and the same sort of. It's just the way it's sort of asking and slicing the data up is different. Okay. So. Any questions on this? So does this, I wonder if this would work. Yes, great. This to me is one of the easier ways to do it. I just was trying to pipe, which has its downsides, as you can see sometimes. Okay, great. Any questions on that? So how sort of, I may not be doing this like comparison between everything, but I want you all to know you can do the exact same thing in dplyr as you can in base R and vice versa. There's just differences in, you can see there's a lot more code here than here, but they're doing the same thing, and sometimes you need one or the other. Okay, cool. So we've covered two commands basically in dplyr, which is filter and select. One of the other things that we can do is actually we can start chaining these together and making new columns, because often what we want to do is we want to select some data, filter it down, and then we want to summarize it or create something from it, right? So let's try that. So let's try something where we actually add a new column, and in our case we have the weight is in just grams, I believe. It's not labeled, but it's just weight. So let's make a column that's in kilograms. That might be something we could use down the road. Whoop, there's a frog. Okay. We're going to use mutate. Okay. So mutate is going to work like this. So we're going to say surveys. And I'm going to pipe that. So now I've loaded the data essentially, right? I'm going to pipe that into mutate. Now mutate works on any data frame, any data that's already in your data frame. And it can do a whole bunch of different things. And what's nice is you don't have to quote things. So we can unquote. Now we're going to, whatever we want to name our new column, I'm going to type here. So let's call it weight underscore kilograms equals. Now, weight is the column I'm interested in doing something with. I'm going to divide it by 1,000 for kilograms.
So that equals you're reassigning. It's the same thing as the arrow.
I'm not reassigning. I'm actually completely new.
But you're assigning. Sorry, not reassigning.
Yes, I'm assigning. So this equals.
So because it's within a function.
Right. Yeah, we wouldn't use the caret assignment variable here. Although you might be able to, I'm not sure. I use equals because we're creating, this column is equal to whatever is here. And you can put a function, you can do a whole bunch of different things. And you can chain these together. So I could, let's run this. And now we should see at the end of this, it's not printing it out, but, oh, here it is. Wait, there it is. There's our new column. Question, somebody has some questions? Anybody? Yeah.
Honestly, I'm not really sure why you've used the pipe there. I don't.
Oh, okay. It's just a way. So instead of why use the pipe? That's a good question. Create a new column. So this would be the same as doing mutate data first, right? So if I hit tab, see the first argument is surveys. Then weight kilogram equal to weight the exact same thing. Okay, the only difference is this is sort of just one of the things that people, when they're using pipes, and particularly in the dplyr world, the nice thing is if you start with your data up front here, it's sort of loaded and everything that you're passing then past that point is this data set. And so it makes it very clear up front that this is the data you're working with, and then these are all the things you're going to do to it. But there's no rhyme or reason that you can do either of these things. Okay. If you're going to pipe past this point, like say if I wanted to mutate and then pipe into the next command, then I wouldn't need to include surveys in that, right? If I wanted to filter or select after that. So it's a matter of preference. It's totally up to you. Yeah.
So you take this create another apartment.
Yeah.
And why is it still showing 13 variables?
Yeah.
Great question. So why is that? Why is the variable still 13 here? Why didn't it add it? Yeah, it just printed it. Yeah, exactly. So this is the key part. So let's assign it. Say this is surveys 2. And now I can use this. I'm going to use this method. And one thing I do, is I like at the end of every pipe, I hit enter, and it abbreviates to the next line or indents, just because I find it easier to sort of see what each line is doing instead of, I could put it all here and kind of keep going, but to read. So that's why I'm doing that. So now let's do the mutate weight underscore kilograms equals weight divided by 1,000. Now, notice there's a little, oh, it went away. There was a little red X there. That's because it was waiting for this closing parentheses. So now if we run this, now we have surveys with 14 variables, right, over here. So yeah, so you can do all kinds of stuff, but you do need to assign it. And the first thing you do usually is assign whatever your variable or your object is initially, and then do stuff to it. Yeah.
What's the variable type DBL?
Double. So that means numeric. It's a double.
The same thing as in?
Integer. So integer is like a whole number, like 1, 2, 3, 4, whereas double would be a decimal.
Oh, okay.
Does that make sense? And I think it also means there's like more, right? You, no, Taylor.
It's the way that your computer, like, is talking.
Right.
But which does
That's right.
find the number of decimals after
Right.
It's not huge. It's
Right.
the number of bits based
Right.
on
Right. So like integer is 32 and double is 64 or something like that.
Let's wave our hands.
Okay. Sure. Great. Okay. Any questions on mutate? One other thing you might be able to do, which is pretty neat with mutate, is you can chain. you can chain multiple things together. In the same mutate call. So for instance, let's do surveys, do again, surveys, and then mutate, weight, kilograms equals weight, 1,000, comma. Now I can add another column, right? So let's say, what are things that I might want to do? What's another numeric? Let's say decimal day. So day divided by 365. Or alternatively, you can use this mutate to call in a column that has just been created, which is also what this is really cool. So weight underscore kilogram is being created here, right? And I could call on this same column here again for a new column. So if let's say weight underscore, I don't know, something crazy. Pounds? Sure. Yeah, if somebody knows that, great. Okay, so times 2.2. There we go. So notice I'm calling this column here. And it has, so this is all, does that make sense that you can do that? This becomes really powerful when you're starting to summarize data, because you can create a new column and at the same fell swoop, you can use that column to do something else. Okay, so now if we look over in our surveys too, we have weight kilogram, decimal day, and weight pounds. Okay. Any questions on that? How's everybody doing? Do we need a quick break? Yes. Okay. Let's take like a 5-minute break and use the restroom or whatever you need to do. People are like glazing over.
So is this like a new version of Melt?
Sort of. It's like a very different. It's different than Melt. Melt's like a reshaping sort of thing. And dplyr is like an actual query and slice and dice and do stuff. Yeah. Yes.
Does it merge them out of space? Based on how you want, but yeah, you
Thing to talk about. Because that's something I often do with month days. All right, let's go ahead and start chugging along. So I want to show how to deal with NAs, because I think in dplyr it's really handy, and particularly if we're doing things like weight or other things, certain functions will do different things with NAs. So it's good to know if you have NAs how to get rid of them and then do some sort of calculation. So let's take our surveys. So let's NAs. Let's start with our surveys, right? And then we're going to filter. If we want to use weight, say we've been doing all this stuff with the weight column, but we want to get rid of the NAs. One of the ways that you can do that is with a, I'm going to call it a bang, an exclamation point symbol at the front. And what that does is it says, don't include these things, or like, don't do this. So it's sort of like, stop, right? But it's, in this case, it's going to eliminate anything that's after this. And so I'm going to say, again, remember is.na printed out true, false, true, false, true, false, true, false, right? So anything I put in here is going to give a vector of those different true falses. Exclamation in front of that is going to say, okay, anything that is true, ignore that, right? So any NAs that fall within this are going to get filtered out. So if I want to filter out the NAs from weight, I'm going to type weight. Okay? Any question about that?
Where's the exclamation point for first of that?
The exclamation point, so is.na is going to give us a true false vector of NAs. Trues being yes, it's NA, right? Filter, remember filter is filtering on rows. So imagine that we have a vector of true falses, and anytime it comes to a true, filter is going to ignore that because we put a exclamation in front of it. Alternatively, if we wanted to
Here in
keep,
front of only the falses, which are.
correct,
okay.
yeah. If we wanted to keep just the NA, I would take this out, and then it would just give me the NAs, the rows with NAs. Got it? All right. So let's now, the cool thing is we can chain this, pipe this into our mutate. And then I'm going to pipe this into head as well, so that we can see that a little bit more easily. We have 6 rows by 14.
But you,
wait,
you don't
that's-
need to include any argument in head because you're piping.
Right.
Right.
So this is empty because I've piped, it's basically filling this for me. So I actually don't even need the parentheses here. I could take these out and it would do the exact same thing. It seems a little crazy, but that's the pipe. Imagine that the pipe is basically just what Michael was saying, is it's taking everything on this side, the left side, and piping it to the right. So essentially what it's saying is this data is going in that parentheses here, but it doesn't need it. It doesn't need that. It already knows that that's what's being used. Okay. I'm going to add a comment here. Okay, any questions on NAs? Kind of a handy trick. So let's do a quick challenge here. On the course materials, let me switch over to lectures, course materials. This one, dplyr ecology. Here. Nope. Is that the one I want to be on? Yes. So I want you to create a new, this one right here. We're going to create a new data frame from the surveys data set that meets the following criteria. It contains only this column and a new column called hindfoot half, containing values that are half the hindfoot length column, those values. And in that hindfoot half column, there are no NAs and all the values are less than 30. So hint, hint, you're gonna have to use some filters, some is.na, you're gonna have to, basically all the stuff we just did. Let's try to put it together and think about how you're gonna have to order those to end up with this bit, right? And you can work with your partner next to you, preferably, talk it out. Let's take like 5 minutes and go ahead and work through this. And then we're gonna jump into something that's grouping by and summarizing stuff. Okay, go ahead. When you're done, put up a green sticky when you've done the challenge.
Create a new data frame for survey.
Okay, so let's come back in here. So one quick thing, we'll talk more about this later. It does not relate directly to the challenge, but it's a good question, and I think it's useful to know. Somebody asked, Chris asked, how do you paste columns together? Like if you wanted to make a new column with, some tab, which is a common thing. And we're going to talk, we will spend, I promise, at least like an hour or spend a lesson on working with date times in R. For those of you that do that, it is tricky, can be tricky, but if you have the right tools, it can be much easier. But one thing that we talked about is when we have a spreadsheet, right, we prefer to split out the year, month, and day, right? Because then it avoids some of the weird things that happen when you're converting dates. So if you notice, this data set has year, month, and day split out. So when you bring that back into R, one of the things you might want to do is paste those together, which is where mutate is really a good tool to do that. So if we wanted to make a date column, I'm going to call it date example, since there's a date function. So we can use paste, which is basically a way to take anything that we want and we can paste it together. And so in this case, I want to paste my year, comma, and then here's the part where you might want to add a hyphen in between. You don't have to, but you can. Your month and day. Now, paste requires one final argument, which is what are you separating these things by, right? It needs to know, like, how are you pasting these things together? And in our case, the default, I think, even might be a comma, but we can explicitly say we are separating these by a comma. Okay? So if I run this, and let's pipe it to head. Example, that's not very, let's pipe it to as data frame so we can see the whole thing.
Wait, what do you mean at the end, pipe?
Oh, see, it added a, oh, it's just a, there we go. That's, so as data frame, I'm basically taking it from the table, where it can make that kind of special printout. And by doing this, I'm saying I want to see the full, all the nitty gritty. That's what I am doing there. But now you see we have month, day, year, right? So you could, it's flexible. You can do all kinds of stuff. We'll talk more about that, but that was a good question. I wanted to show that for folks interested. Any questions on that? Yeah.
What does data type? The result thing.
It's a character at the moment because it's pasted those things. Remember when we paste things together, it defaults to the, a certain data type, and in this case, it's character. We'll talk more about that. Dates and times and pasting stuff together is kind of okay. So the challenge. What was our challenge, and who has a potential solution? So first, let's see. It says new data frame from the survey's data that meets the following criteria. All right, so let's make a new data frame. Surveys new. I'm assigning that, and then help me out here. Obviously, we would want surveys. But what do I do next? Mutate. Okay. Hang on a second here. There we go. So we're creating hindfoot half. Is that right? Half. And what does that equal to? Okay. And what? Anybody else? I hear filter and select. Which one should I do? Select? All right. We'll do select. Select what? And hind foot half, right?
Why does it only work with that comma and not?
Oh, that's a good question. The and symbol is specific to filter because it is chaining commands together in a way it's querying across lots of rows. Whereas in this case, and would mean it's trying to match both of these commands at the same time. Slightly different meaning, but that's a good question. I don't know, have a better answer than that. Does that make sense? Ish. And is, I would say, pretty much specifically you use it in filter. Okay. All right, but that's a good question. Hind foot half. Okay, now what? Type that. Okay. Now filter. And what are we filtering? Okay.
Well, I guess.
Go
I
ahead.
did it, first I did an exclamation point in and then you do an and then I put half equals.
Good, like this, and then and.
Yeah. And then I put half equal, or yeah, is less than, or it's great. What are we measuring?
Less than 30?
All values are less than 30, so.
Yeah. Right. Okay. Awesome. So let's see what we get. So we've got surveys new 31436. Is that right? So it's still a pretty big data set. So let's look at this, the dimensions. There we go. So 31,000, 2 columns. Did everybody get and at least end up with something that's the same? What happens if we switch these around? What if we put our filter in front of our select? Shouldn't matter, right? Yeah. The important thing is that we created this column first because that's everything else relies on that after that. So mutate does have to come first, right? Cool. Awesome. Good job, y'all. So now you start to see the power of what you can do with this in like your own data, right? You read your data in, you want to look for some certain thing, or you want to get rid of your NAs, and you want to spit that back out to do plotting or analysis. That's what this is really designed for. Okay, so I'm going to quickly, not too quickly, hopefully, but we're going to introduce the 2 other main verbs that are used in dplyr, which is group by and summarize. And this is also where you really begin to see the power of why this is such a really great tool, in my opinion. Maybe a few other people too. Group by. Okay, so the way data analysis usually works when you're sort of wrangling your data, right? You're defense against the dark arts, and you're like, all right, this is how this is going to work. The process that you should typically try to stick to is something called split, apply, combine, right? When we are trying to filter through our data, we want to split it up by some metric or variable or category. We want to do something to that. Maybe we want to create some new columns or analyze that data, and then we want to summarize it. And that sort of circle is something we do all the time with our data. You may not even realize it, but that's what you're doing, is splitting, applying, and combining. Almost all the time when we get a new data set, when we're cleaning it up, and what we end up with, that's kind of the process, the circle that we go through. If you're explicitly thinking about that, it can really make your life much easier, particularly using this dplyr approach, okay? Okay, so what we want to do is use group by, which is this really cool function that allows us to group by a given column or columns. We can do multiple columns. So let's say surveys. I don't know why I keep auto-filling there. If we want to group by, you'll see it pops up and there's a whole bunch of options. But the main thing we want is a single thing. So let's group by sex. So we have all these little rodents and we want to know what they're grouped by sex. And then we want to summarize something based on that grouping. So summarize is similar to mutate, except to create a new data frame. Right? Mutate works on the existing data frame and adds a new column to the existing data frame. Summarize is creating something completely new. So that's the main difference between the two. You can use them all together, but be aware that summarize, we're making something completely new. So we're going to summarize, and now it's the same as mutate in the sense we're going to do mean weight.
Summarize is summarize.
Yes, it is not. So yes, one is the Amy would say the correct spelling, one is the incorrect spelling. But so the whole tidyverse package, that series of packages, is written by a guy named Hadley Wickham. If you've heard his name, great. If not, you'll hear it again, I'm sure. He is Kiwi originally, and so all his spellings are the British style. So it is interchangeable. When the package first came out, it was all you had to use the summarize with like an S, and people gave him a lot of hard time. And so he finally sort of made it work for both. So anyway, you'll see, if you see those, don't worry, it works either way. So equals mean weight. Now remember, we had some stuff in the weight that was NAs, right? There were a bunch of NAs in there. So the mean function, if I just do this, let's try it, and run this, is what I get. That's not very helpful. It's because there's NAs in there. But conveniently, mean, if I hit comma, I can't recommend enough using tab in all ways, shapes, and forms. It will give you lots of information. Notice it has an na.rm flag here. And if I just hit enter and then true, now I run this. There you go. Okay, boom, we have a nice little summary table. It also told us something interesting. We have actually unidentified, probably individual animals that they didn't sex. They couldn't tell whether they were male or female. This is all the mean weight for all of those unidentified ones, which is interesting because they're really large, right? They're very heavy animals. So now we can sort of do this across multiple columns, which is neat. So now let's say we want to do the mean weight for every species that we have and sex, species and sex. So how might we do that? Using the same thing. Group by sex. Now this is where it's cool. You're going to start changing or adding more columns. So let's say species ID. And then the same thing here. Summarize. Mean weight. Mean weight. NERM equals true. There we go. Now we have this really nice table that's actually starting to become pretty interesting, and we can start playing with our data. Notice it's sort of not printing all the rows for it. It's sort of appending that or abbreviating it. How might we, if we wanted to see everything, what are some options for us to do? Right, assign it to an object. Exactly. So let's go ahead and do that. So I don't know where's my mouse? There it is. let's assign this to surveys 3. Notice it didn't print anything out, but down here, if I click on surveys 3, now I can look at this right here and query my data. And it's quite long. But now you start seeing, okay, here's the ones that don't have the sex, and either they didn't collect it or whatever it might be. But notice there's a bunch of NAs in here too, right? So even though we said don't include the NAs, how might we want to, if we want to clean this up, this isn't very helpful. Let's try to filter those out first. So let's, I'm going to copy and paste this to save typing. I apologize. But before I even do my grouping, in this case, let's filter our NAs out. Is.NA weight. One day I'll be able to type weight correctly the first time. Species ID, and then the cool thing is I don't necessarily need this NA remove in here because I've already filtered them out. But you know about that if you would like. So now we've basically split. So we've filtered out our NAs. We're splitting our data frame up by sex and species ID. We're applying and summarizing by mean weight. We're applying a function of mean to the weight and summarizing it. So if we run that, and then let's take a look at that. Again, I'm clicking on the surveys 3 here. And now we have a bit of a cleaner data set in the sense that we can see everything in here. We can see which species ID we've got. Pretty nice. So any questions on that? No? Okay. Awesome. Okay. And I'm going to, so let's see here. One thing you can do also to, which I haven't mentioned, if you don't want to assign, like if you're just querying this, is using print. The print command is kind of handy in that it will allow us to print either the whole data set, or I could say a specific number of rows. So I could say n equals 15, and it will print just those 15. Or if I want to print all of them, I think I leave this blank. Or no, I think I'd have to specify like 80. Print all of them. Okay, so that's just another way to view your data. Okay, we are going to pause there. I think that gets the general gist of things. There's a few other commands we'll talk about. Tally is one of them. Group. There's a lot of things you can do now that you have this group by and summarize, because within summarize, you can start doing things like counting the number of species you have, taking the mean weights and lengths. You can figure out how many distinct species you have. There's a whole bunch of little sub-functions within dplyr that are really handy for summarizing data. But I want to give about 5 minutes to talk about sort of the assignment that we would like to have folks do this ongoing week instead of me emailing you. And I will, just to show of hands, how many are you okay emailing and put a posting on the website? So you might get 2 emails, but all right, cool. I will do that. So whatever Mike's gonna show us right now we'll post it and email it out, right? Instructions? Yeah, all right. Okay. So you want to switch over, or you just want to?
Do you have the Google Doc up?
I do.
And do you have your Dropbox folder?
I do.
Can you
Yes.
double click the assignments text?
Yeah.
I just dumped it into the Dropbox. If everybody could pull up the Google Doc. I've highlighted the website that you should bookmark. It takes you to the ends webpage. That's where the discussion board will be. Send you also an email. But in the future,
So here.
yeah, scroll up a little bit, all the way to the top. So this here, bookmark that site. That's the discussion thread. That's where the assignment will be posted. And then we'll also email you, but get in the habit of looking there for assignments.
Do you want me to go there?
No, because it's not.
Oh, not up there, okay.
In your Dropbox, there's the assignments text or something like that. It's just an HTML.
Hang on, we're.
Basically, it asks you to use some of the deployment verbs that you've learned today. There's a basic one, and then there's a more advanced version also. So there's two parts. There's doing the assignment, and then there's that code review also. So you're going to use the link that you see in the email that we're going to send out to find out your code review partner.
Where's, sorry, in our,
It's just free floating.
this one?
Yeah, double click that.
Perfect.
Okay, so it's gonna. This is what you're gonna get emailed. This is what's gonna be up on the discussion board. Part one is going through creating a new script in the repository that you have. And you can scroll down just a little bit. We're gonna use some of these deploy verbs. You're gonna take these lines of code and rearrange them in order to accomplish the task that's there. So for that first point, you're not writing any new code. You're just reorganizing those lines of code that are up there in order to accomplish that task. If you're feeling ambitious, you can do the second task here, which you're starting from a fresh screen. And then the code review portion is here. It's exactly the same as last time. So you're going to try to run somebody else's code by copying the raw file. Yeah, so we'll send those details out to you. And if you would mind going to that collaborative notes document and filling out the end time survey on the case of class and the one pleasant thing and the one thing that we work on.
Thanks, y'all. It's on the Google Doc right here. And as always, feel free to email us or ping us if you have questions.
Is it the same partner as last time?
We will restore your partners.
It's restored.
It's restored. Did you already do that? Yeah. All right. It's restored.
There's a second sheet in that Google sheet with this week's assignments.
It was in a.
Let me find that. I can double check.
Okay, so that assignment just went live on that weekend.
So they just. Okay, cool. All right, thanks, y'all.